Alrighty. Also, I need to ask them for a new mic. I need that little black microphone back because I don't know how well the sound is going to work from the computer picking me up. So we'll see. So hopefully you'll understand if the video or excuse me audio quality is garbage on YouTube for these first few lessons while I get a better microphone. But we'll just see what happens. Alrighty, guys. So what are we doing? Starting off the year talking about it says real numbers. Honestly, what I want you to review from section P1 is just your exponent rules. These first couple boxes I have up here, these are just to make sure that you learned about interval notation in Algebra 2, honors or Algebra 2. Not everybody goes over it. I know that I do in my class because I teach pre-calc and I want to make sure that everybody learned it. So I'm not trying to insult any intelligence. I'm just making sure that I throw it out there that I will be using interval notation this year for any span of numbers. I won't be using any quality symbols. I'll be using intervals. So what you're looking at here is brackets and parentheses. I know this looks like a coordinate, but it's not when we're talking about a span of numbers. And again, I'm not trying to insult intelligence, it's just going to remind everybody what these mean. If you have a bracket, we say that this is a closed interval on one side at least, but this is closed completely because it's brackets on both sides. And brackets can be thought of it as meaning or equal to. That means including that number, beginning at a and including a. So not only is it the boundary, it's also part of the span. And if you were going to put it on a number line, you would use either a closed dot, instead of an open dot, or a bracket. It's completely up to you which one you would use. So parentheses are going to be a boundary, but not including that number. So there's no or equal to bar if you were writing it as an inequality. That's what that means. Now, do I need you to know open, closed, half closed? No, I don't care about that. I just want to know if you know parentheses on a span of numbers means that's the boundary, but don't include it. Bracket on a span of numbers means that's the boundary and it's included. Okay. And again, I'm just out of curiosity, show of hands for people that already knew that. Most. Fantastic. If not all. Almost all. Fantastic. But that's why we're going through it. We say that A and B are the endpoints of the interval. Whatever. I'm not too worried about the words. I just need to know. Do you know that bracket means include and parentheses means does not include? And this is the exact same information. It's just showing you what happens at the infinities. So when you see things like that is when you talk about domains of functions a lot or range of functions a lot. Basically, you cannot put a bracket on an infinity because infinity is not a number. Infinity is an idea. You're never going to get there, and since you can never get there, you can't include it. Intervals should always be written from small number to big number. Positive infinity is the biggest thing that exists. So if you have to write positive infinity, it'll always get written second. Negative infinity is the smallest thing that exists. So if you have to write a negative infinity, it will always be written first. If you were going to color in a number line, you would obviously just color in the arrow. You notice there's no examples of that in the notes. You guys are too smart for that. I'm not going to be doing that with you. But just showing you what it would look like. So where does the real review start then, now that we've got that out of the way? Because like I said, almost everybody knew that material, just had to, dust it off and bring it back to the front of your brains. What I really want to start with is properties of exponents. Now, you should have seen them in Algebra 1 honors. I don't know how well it was learned because I know that the Big Ideas textbook just burns through these things like they're so easy. You can learn and master everything in 2 days. Well, they're wrong. And then it comes up again in Algebra 2, and I find in Algebra 2 there's a lot of struggle. I've never had Algebra 2 honors, but I do know in my regular Algebra 2 classes I see a lot of struggle here. And I'm gonna be real with you, I see a lot of struggle in the pre-calc area also and that's even with my advanced students. Something about these things just escapes people. So just gonna practice a little bit with them, and we will be using these concepts as we go forward this year. They do matter. First one on this list is what happens when you multiply two numbers with the same base. Well, if you multiply two numbers with the same base, like x and x to the third, you would get x to the fourth. That's because you just add the exponents. Again, not trying to insult intelligences. So if multiplying two numbers with the same base has its adding exponents, then it should make perfect logical sense that dividing two numbers with the same base has you subtracting exponents. And it's always going to be top minus bottom. Always going to be top minus bottom. they're showing you that A can't be 0. You can divide by 0. This one's showing you power raised to a power. Anytime you have a power raised to a power, multiply those exponents. Order of the multiplication doesn't matter because it's multiplication. Now this one, a lot of students like to say that this is distribution. What you have here is a set of parentheses raised to a power, but specifically in this set of parentheses, there's multiplication in between the A and the B. Now this is not going to be the same thing, so I'm just going to put a little dot there. You don't need to. I'm just indicating that it can be thought of as being A dot B raised to the N. I just got lucky ducky. Thank you, sir. Back. Not just sorry. Tell you what, for now, just go ahead and grab one of those, each of those two pieces of paper off that table. And I got an open seat right here next to this gentleman whose name I currently can't remember. What is it? Lincoln. It's Lincoln. Lincoln, make sure you introduce yourself to this gentleman here. And all of that is on the video. Congratulations. You being introduced will be on YouTube. Okay. What was I saying? Oh, yeah. Right here. Multiplication between two numbers. If there's an exponent on the outside, I like to say you apply this exponent. It's application. It's not distribution. It's application. Distribution is specific to multiplication. Now, what you can't do, and boy, oh boy, students try to do it all the stinking time, is you cannot do this if there's a plus or a minus in between. So you're not allowed to do it here. That's a big fat no-no. It doesn't work. It's never going to be true. And if you don't believe me, you're welcome to pick a number for A, B, and N. Stay away from ones and twos because they do weird things. And you'll see that it's not true. Okay. Now that won't stop a lot of you from trying. I see my IB students do it all the time. I'm like, you gotta be kidding me. How many times have I told you you can't do that? Okay. So it only works when there's multiplication between the bases or objects inside the parentheses. Okay. Now here, when there was multiplication inside the parentheses, the exponent got applied. So hopefully logic would dictate to you that division inside the parentheses would also apply the exponent. So you got a fraction on the inside of a pair of parentheses, and there's an exponent on the outside. Both the numerator and the denominator will get that exponent. Boom. Exact same idea. It gets applied to the top and the bottom. It's not distribution, it's application. This rule here tells us anything raised to the 0 power is 1, except for 0 to the 0. That is a calculus thing called an indeterminate. You will find out about that next year in AP Calculus. And this one is telling you how to handle negative exponents. I want you guys to try to stay. Oh, he's passing out on me. I want you go get a sip of water. It'll help. You sure? No, I'm serious. It won't be a big deal for me. No? Okay. It'll help. Even this walking. It'll change your blood pressure, which gets fresh oxygen in your brain. Neuroscience. Thought you were just learning about math today, huh? Okay, so this one tells you how to handle negative exponents. I would like you to stay away from the phrasing that negative exponents flip things over. That's dangerous. Okay. Instead, what I want you to say is anything when the negative exponent moves to the other side of its fraction bar. So you have an object on the top of a fraction with a negative exponent, it goes to the bottom, exponent turns positive. You have an object on the bottom of a fraction with a negative exponent, goes to the top, exponent turns positive. So when would a negative exponent flip something over? When would that happen? In a situation like this. If this outside exponent is negative and there happens to be a fraction on the inside, then the entire fraction, the net result is, flips over. But the reason why is because the top would have a negative exponent, which would force it to the bottom. The bottom would have a negative exponent, which would force it to the top. So that's when you can use the phrasing flips over. I just want to be really careful with that, because sometimes if you say it flips over, someone thinks that the whole fraction turns upside down. Only objects with negative exponents move. Yeah, I think I beat that dead horse enough. Got 3 examples for us, and I'm pretty sure we're blank on the back. Yeah, that's it. It's 3 examples, and we will move over to the P.2 notes. Sorry, I just got these lips. Still trying to figure out how to use them. Those are jokes, people. You can laugh. Okay, what do we got? Got a few different rules going on here, which was the idea. Make sure I gave examples that can highlight several of the rules. And in the first one, we're talking about multiplying numbers and multiplying see objects with the same base. There we go. Trying to pick a good color. Go with purple. Hello. And because this is multiplication, the order in which you do this really doesn't matter much. But I just like to keep things in alphabetical order, and I like my numbers in front of my letters. So what we're going to do is, and I'm going to show all the work. If you can just see the answers and don't need to show work, that's fine. I understand. I just want to make sure that my notes are very detailed because it's going to YouTube. Like, subscribe, Patreon below. You know what I mean? So, oh, that's a joke. You weren't here yesterday. It is on YouTube, but it's not monetized. What we have here is a 2 times a 5 sitting in the front, and I have an a times an a squared, and then I have a b to the third times a b squared. Now again, if you can skip over this step, awesome, cool, that's great. I just want to make sure my notes are detailed. And then you just go from there. 2 times 5. 10. Now right here, with the a and a to the second, this can be thought of as being a to the first. And this is going to be that very first rule where we are multiplying two numbers with the same base. So when we multiply a and a squared, we are going to get a to the third because it's going to be a to the 1 plus 2. And then again, hitting the same rule here, b to the third times b squared. Again, this property is being used, multiplying two numbers with the same base, adding those exponents, b to the 3 plus 2 or b to the 5. Very simple. So when you're doing your homework tonight, do I expect to see this kind of work on a question like this? No. I mean, you're welcome to, but I get it. You can probably see the answer without doing the work, and that's fine with me. I know what kind of questions need work and which ones don't. I'm not going to force you to show work that you could have done in your head. Now for question B, it would be great if I could see one step of work. That would make me really happy. And that one step of work would be moving the object to negative exponents. So if you could rewrite this expression with only positive exponents and then go direct to the answer, thrilled. Makes me really happy. Change colors. I'm feeling pink. Amazon Basics pink. Get it working again. There we go. Cool. Give myself a fraction bar, and I go piece by piece, and I ask myself, does that need to move or can that stay? So I see this u squared. That exponent's positive. Stays put. This v has a negative exponent. It's not going to stay where it is. So this v will need to move to the bottom of the fraction, and when it comes to the bottom, its exponent will get turned positive. Then I come to the bottom. This u, same idea, negative exponent. It gets to move to the top, and when it goes to the top, its exponent will turn to a positive 1. Do I need to write the 1? No, just detailed notes. And lastly, this v, positive exponent, stays put. Now we can jump directly to an answer because on the top and on the bottom, we're going to be using the exact same property that we used right here. We're going to be using the exact same property that we used right here with this green brace. And that is when you multiply two numbers with the same base, you add their exponents. So on top of this fraction, I have u to the 2 plus 1, or u to the 3. And on the bottom, I have v to the 2 plus 3, or v to the 5th. Ta-da! Last example before we move on to the second prerequisite section of the textbook. Now this one is reminiscent of what I was talking about up here when I was saying what happens if the entire set of parentheses has a negative exponent. This is an opportunity for us to use the idea that, yeah, I could apply this exponent to here and here. And if I did that, both the top and the bottom would have negative exponents, which means both the top and the bottom would have to move. You're welcome to do it that way, or instead realize negative exponents do make fractions flip over, not objects, whole fractions. If whole fraction is a negative exponent, it does flip over. So 2 over x squared, and that would change the outside exponent to a positive 3. Do you have to do it this way? No, you could do it the way I described. Apply the exponent, move the things with negative exponents. Completely up to you. I will never be the kind of person that dictates a method. Let me move these papers, make sure that everybody in the back can see. Hopefully they're seeing over my head and the panel or the monitor okay. Even over there. Good? Okay, great. Awesome. And now, what goes good with green? Purple, pink, blue, blue. Feeling blue. I will apply this third power to both the top and the bottom. But they're going to work differently for the top and the bottom. See, on the top, on the numerator, I just have a 2. So what I'm saying here is I'm going to be working with a 2 to the third. I will show this step just to have detailed notes. If you can skip over this step in your homework, I'm fine with that. I just need to see that you actually knew what you were doing. If you can skip some work, fine. I'm cool with that. But then down here, what we're dealing with is a power to a power. So I am going to show this in one extra step so that I can highlight what rules we're using. When the numerator is just 2 to the third, 2 times 2 times 2 is 6, 2 times 2 times 2 is 8. But on the bottom, what we're dealing with here is, just make sure we can see it on the screen, this property right there. Jokes, where am I? Right there. Power to a power. That's what's happening down there with that x squared to the third. When you raise a power to a power, your job is to multiply the exponents. So down there, you will get x to the 2 times 3 or x to the 6. How do you feel about that? Calm, cool, and collected? Maybe you were a little sketchy before, but it's okay right now, maybe? Well, good news is when you're working on your homework, if you get stuck, shoot me a remind. If you need to ask me homework questions tomorrow, fine, we'll make it happen. Good? Questions, comments, concerns before I move on? Okay.